In this video, I'm going to take a look at testing a hypothesis for a mean. Now, depending on whether you know the sigma, which is the value of the standard deviation of the population, if you do know it, it will be a Z standard normal test. If, on the other hand, you do not know the sigma, the standard deviation of the population, it will be a t-test. I'm going to look at both. Okay, so first we'll look at a hypothesis test of the means when sigma is known. So here's an example. We have, according to WeatherBug, the mean daily high for December in a large Florida city is 76 degrees. The local weatherman suspects that this temperature is not accurate. The hypothesis test is performed to determine if the mean is actually lower than 76. So this weatherman thinks that it is lower than 76. That's the claim that they're making. Assume the population, notice the statement says, assume the population standard deviation is 5.6. That tells you this will be, your test statistic will be Z equals, not T equals. The mean daily temperature, 40, N is equal to 40, is 74 degrees. That's my X bar or mean. I'm going to use an alpha of 0.01. Does this data provide sufficient evidence to conclude that the mean temperature is lower than 76? Well, if I go into Excel, my spreadsheet, and I look specifically at the, let me move this up just a little bit. Okay, I'm going to look at a sample mean, Z1 sample mean tab, and I'm going to put the numbers in. So I put a 76 as my claim, as my number, which it differentiates less than, greater than, and my sigma is 5.6. Notice it says sigma. My X bar is 74. My N is 40. I put in my alpha 0.01. I get a test statistic. Remember my formulas that I gave you for test statistics. You can calculate it out, but there's the formula written in terms of Excel. My p-value, since this is a left tail test, right, because the null or the alternative hypothesis is less than, I use the p-value from the left tail, and then I state my statistical conclusion. Well, I look at the p-value, it's 0.0119, the alpha is 0.01. Well, 0.0119 is greater than the alpha, not by a lot, but it's greater than. Therefore, I will fail to reject the null hypothesis. So what does that mean? Well, since I didn't reject this one is holding true, therefore I haven't proven that it's less than. And so I'm going to state that there was not sufficient evidence to reject the null hypothesis in favor of the alternative that the temperature was actually less than 76. So what I'm telling you is that 74 in a sample, in this particular sample, at this particular alpha level, is not sufficiently less than 76 in order to be sufficient for statistical purposes. Okay? That's the final conclusion. Now, let's take a look at a mean where alpha is unknown. So here's a problem. We have a local tire store suspects the mean life of new discount tires is less than 39,000 miles. The store selects randomly 18 of these new discount tires to test the claim. When the tires are tested, it's found that the mean life of the tires is 38,250 with a sample standard deviation of 1,200. Assume a distribution is normally distributed. Notice this time they tell you the sample standard deviation, not the population. So when we have an alpha, my null is equal to 39,000. My alternative is less than 39,000. This is again a left tail test. My test statistic, where did they come from? Well, if I go to not the Z sample mean, but the T sample mean. Same concept though. I'm going to put in my claim, 39,000. My S, my sample standard deviation is 12,000. The X bar that my sample got was 38,250, and my sample size is 18. It's important to have the sample size. I have an alpha of 0.05. And so I'm going to put in a 0.05 here. Okay. And this is going to give me a test statistic of 2.65 and negative 2.65 and a p-value in the left of 0.0084. Okay. And I come back here to my, and I end up with my test statistic, my p-value. I compare my p-value to my alpha. Notice the p-value is less than alpha this time. Therefore, my statistical conclusion is that I will reject the null hypothesis. And my final conclusion will be that there is sufficient evidence to support the claim that the new discount tires are definitely less than 39,000 miles running based on this sample. Okay? So you have different ways you can do hypothesis tests. You can look at them through the traditional way. You can look at them through a p-value method. You can also take a look at confidence intervals and do that. So take a look at those things. These are two examples. Hopefully they'll get you started on whatever homework you have.